Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face Trending List, published on February 2nd, 2026, just 2 days ago. It introduces a challenging new benchmark called VDR-Bench that exposes how current models often cheat by relying on text rather than vision, and proposes a new crop search strategy that boosts accuracy for top models like Gemini 2.5 Pro from about 16% to 30%. The paper is titled Vision Deep Research Benchmark: Rethinking Visual and Textual Search for Multimodal Large Language Models. And as we'll see later, the results essentially force us to rethink how we design these visual search agents for the real world. So Figure 1 breaks down the two main flaws in existing benchmarks that this paper aims to fix. First, looking at the left panel, we see that many tests are not truly visual search-centric. In the top example, the question itself leaks the answer through text clues like dates, allowing the model to bypass the image entirely. Below that, the figure shows models solving problems just by relying on memorized knowledge, like recognizing a jersey, rather than searching. Then, the right panel highlights that current benchmarks rely on idealized whole image matching, which fails in messy scenes where you actually need to crop and zoom to find details. Addressing these gaps, Figure 2 presents the breakdown of VDR-Bench. The central pie chart reveals a diverse mix across 10 domains, including games, sports, and science and technology. The surrounding examples highlight the complexity. Specifically, look at the science and technology case in the top left. The model must visually locate a specific audio console relative to the monitors, identify it, and then perform an external search to find its input specifications, which clearly aren't visible in the image. Table 1 provides the hard numbers backing up those claims. It compares performance across 5 existing datasets versus VDR-Bench on the far right. Notice how on benchmarks like simple VQA, Gemini 2.5 Pro achieves nearly 70% accuracy with just a direct answer, meaning it doesn't need to search at all. Even more telling, looking at the text search rows for older benchmarks, we see significant gains, which confirms that models can often solve these tasks just by searching text clues. In stark contrast, look at the VDR-Bench column. Performance collapses to single digits, around 8 to 10%, proving that this new dataset genuinely requires visual verification that current models struggle with. To ensure questions genuinely require visual work, Figure 3 outlines the rigorous 5-stage construction pipeline. It begins in the top left with Step 1, where annotators manually crop salient regions, like a specific face, to run targeted visual searches. Next, Step 2 validates the resulting entities using both humans and models. Then, looking at the bottom center, Step 4 is crucial. It uses knowledge graphs to expand simple questions into complex multi-hop reasoning tasks, which finally pass through the solvability checks in Step 5 on the right. With the pipeline established, Table 2 presents the performance comparison across different models and domains. Focusing on the Gemini 2.5 Pro section at the top, we see the impact of the 3 strategies. In the direct answer row, accuracy is extremely low at just over 8%, confirming that models cannot simply guess these answers. The middle row shows that adding cropped image search and text search, labeled CIS plus TS, doubles performance to roughly 16%. But the crucial finding is in the bottom row. The multi-turn visual forcing method propels overall accuracy to 30%, proving that iterative visual grounding is the key driver of success. So, Figure 4 visualizes exactly why that iterative approach works better by plotting overall accuracy against recall. The x-axis tracks correct answers, while the y-axis measures entity recall, basically whether the model found the correct object. In the legend, triangles represent the baseline search mode, and diamonds show the multi-turn visual forcing strategy. Take the blue markers for Gemini 2.5 Pro. The diamond sits far to the top right of the triangle. This consistent shift across all models confirms that the new strategy boosts accuracy, specifically because it successfully retrieves more relevant visual evidence. Wrapping up, 2 main takeaways stand out. First, VDR-Bench exposes a critical laziness in current multimodal models, showing they fail when they cannot rely on text shortcuts. Second, the significant gains from the cropping strategy imply that future agents must adopt iterative, human-like workflows to solve complex visual tasks. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.